Alright, I'm here to do a quick video on similar triangles and proportions. Um, we're going to go into a couple assumptions. One is that you've watched my other videos on similar triangles, or you already know something about similar triangles. Here's the deal. I'm going to say the triangle ABC is similar to triangle RST, and I'm stating that right now. I'm also going to show that ABC and RST are right angle triangles, so that should be helpful. In my last video I said, if you know that the two triangles are similar, here's the deal. You can set up their sides and show that they're also proportional. I like to, with right angle triangles in particular, I like to set up a chart. And what I do is I say small triangle, big triangle, and you could use the actual letters. And then I say altitude, base, hypotenuse, and then I just fill them in. And it's nice because I already know everything I need to know about my small triangle. I know that my altitude is 3, my base is 4, and my hypotenuse is 5. I don't know anything about, I do know that my big triangle, the altitude is 9, right? I don't know anything about my base, I don't know anything about my hypotenuse. So if I want to find the base, the nice thing about setting up a chart is this. If I wanted to find this, and I'll call it B for base, the proportion's already set up for me. So I can just say 3 over 9 equals 4 over B. And it's a proportion, and a proportion is an equation that states that two ratios are equal. So I can cross multiply. 4 times 9 is 36. 3 times b is 3b. And so now I just divide by 3, and I say the value of b is 12. Now, I'm going to erase that. I'm just going to put in 12. And what I'm hoping you're noticing right now is 3 times 3 is 9, 4 times 3 is 12, so this should be 15. Now, you could say 9 squared plus 12 squared equals c squared, and find out what that is using the Pythagorean theorem. Or you can use another proportion. I'm going to say 4 over 12 equals 5 over h. I'm going to call this h for hypotenuse. And I cross multiply, I get 4 times h, which equals 5 times 12, which is 60. I divide by 4, and I get h equals 15. And you might say, oh boy, he's quick with that multiplication on that one. Well, or division. But here's the trick. First of all, I knew it was going to be 15 because I noticed that 3 times 3 is 9, 4 times 3 is 12, so 5 times 3 is 15. But remember, there's 60 minutes in an hour. Quarter of an hour is 15 minutes. So I get 15. So take a look at this. I'm going to put in that this is 12, and we're going to assume these are all centimeters, and I get 15. There's something else I want you to notice, and this is actually really quite clever. Oh, shoot, I didn't mean to do that. All right. If you look at their perimeters, you should be able to make some kind of hypothesis about this. If you look at their perimeters, 3 plus 4 plus 5, well, that's 3 plus 4 is 7 plus 5 is 12. If you do 9 plus 12, you get 21 plus 5 is 36. Take a look at this. 12 times 3 is 36. Everything's in proportion. If I were to just test this, and I said 5 over 15 equals 12 over 36, well, I multiply 5 times 36, I get 5 times 30 is 150, 5 times 6 is 30, so that's 180. And then 12 times 15, 10 times 15 is 150, 2 times 15 is 30, so 150 plus 130, or plus 30 is 180. So even their perimeters are in proportion. And that should make sense logically because it's just the sum of these, of the sides and the sum of the sides. Now here's something that might not make so much sense. If you label these as centimeters, right, and then we go into the area. Now remember, area equals 1/2 base times height, but more importantly, area is measured in centimeters squared. So you might be a little confused if you check this out. You say 3 times 4, area equals 1/2 base times height, and you're going to say 3 times 4 is 12, and half of 12 is 6, so I get 6 centimeters squared. So I'm going to put in 6. Now, our assumption would be that this would be 18, but take a look what happens. This is a little troubling at first, but if you think about it logically, you're going to say, oh, maybe it's not that. 9 times 12 is 108, and half of 108 is 54 centimeters squared. Is that right? Let's see. Yep, that's 54 centimeters squared. And you can see right now, 6 times 3 is obviously not 54. However, there is something you can do. If you take any side or the perimeter, I'm going to say 3 over 9. I'm going to highlight this side. And I'm going to take a look at this. What I want you to remember is that right now, this is centimeters squared, and this is just centimeters. If I were to square this to make the two equal, I would have to square this. So what is 3 squared? It's really 9. And what's 9 squared? It's 81. So now, I'm going to rewrite this as 9 over 81 equals 6 over 54. If you were to cross multiply, 6 times 81 is 6 times 80 is 480, plus 6 is 486. 9 times 54, I'm not going to do off the top of my head. Actually, sure I will. 9 times 4 is 36, 6 is 3. 9 times 5 is 48, or 45, plus 3 is 486. So it does work. What I just noticed as well was, if I multiply by 3 squared, I also get 54. And I don't know if that's always true. I bet it probably is, though. In any event, that's going to be something up for you to figure out. And what you can do is you can do very, very simple triangles. 1, 2, find the area of that. Let's say 4 and 8, right? And so we'd say the area of this one is 1/2 1 times 2, which is 1. The area of this one is 1/2 of 32, which is 16. And so we could say 1 over 2 equals 1 over 16, but we'd have to square this. And this was a relationship of 4. Take a look at that. There's 4 times as big. I bet it does work. In any event, I'm not going to ramble. Check it out for yourself. That's all I have. Good luck. Enjoy.